In this tutorial, you'll learn how to simplify radicals. Let's say you're given the square root of 12 and you're asked to simplify that root. How would you do it? Well, in order to simplify a root, or an irrational square root, you need to write the radicand, that's the number underneath the square, root sign. You need to write that as a product of two factors, and one of those factors must be a perfect square. So let's review. These are the first 15 perfect squares. Now this list certainly keeps on going, but most of the times the number that you'll be given will have one of these as a factor. You're going to use these to try and divide them evenly into whatever your radicand is. So if this is my square root expression, the 12 is known as the radicand. So I'm going to try dividing 12 by some of these perfect squares. Now obviously I can't choose something bigger than 12, so all of these would be out. So what I do is I pick up my calculator and I type 12 and I start dividing by these perfect squares. Now there's only 3 here and it's easy enough, but when you're doing that, 12 divided by 9, if you get a decimal value, then that means it's not a factor. 12 divided by 4 is. So 4 and 3 are known as the factors. So now that we know we need a product of the largest perfect square factor and another number, and we've done the math on our calculator, we could rewrite the square root of 12 as 4 times 3. And we could separate this product into the square root of 4 times the square root of 3. And the square root of 4 is a perfect square. So the square root sign can disappear, and the number will come out as the root, known as 2. Let's try that again from the beginning. Let's say you have the square root of 75. We're going to try and break this 75 up into 2 separate factors, with one of them being a number from this list. Now obviously, it can't be a number that's higher than 75, so I'm not even going to try these. Your best bet is to start here from the highest value. Now I know that 64 is pretty close to 75, so there's no way it's going to be a factor. So I'm going to go down the list. So 64 can't, because the first thing I could times it by is 2, and it's going to be way bigger than 75. The same with 49. It's about 50, and if I double that I get 100. So I can start by dividing 75 by 36 if I'm not sure. Fraction answer or decimal answer, so that's not a factor. And then I try again with the next whole number factor, which would be 25, and that does work. So 25 is my perfect square factor, and 3 was the other factor. Again, since I've split them up, this one can be square rooted, and the square root of 3 remains. This is the actual final answer. This root has been simplified. Let's try this one more time. So I can't divide by anything that's bigger than 98, and pretty much I can't divide by anything that's more than about half. So 98 is about 100, so I'm looking for numbers less than 50. Oops, 49 is not less than 50. So here we go, we open our calculator, we type the 98, and we start dividing. 98 divided by 49, is 2. So there are our 2 factors. You can write them under one giant radical sign together, or you can write them separately to remind you that one is being rooted and the other is staying underneath. One last time. So the square root of 72, I'm going to start dividing here. And let's see, 72 divided by 49, decimal answer, not a factor. 72 divided by 36, that's a whole number factor. So the square root of 72 can be written as the square root of 36 times the square root of 2, which gives us 6 square roots of 2. Let's take a look at an example where there's already a coefficient outside the radical sign. In this case, we're going to use the same procedure as before by dividing 108 by any of these perfect square factors. So let's see, 108 divided by 49. Nope. 108 divided by 36. Yes. So 108 is 36 times 3. Now the 2 is already out here. The 36 is going to be released as a 6. And when he does, he's going to come out, he's going to multiply any coefficient that was already out there. So these two will multiply together to become 12. And the square root of 3 remains at the end. And that is how you simplify radicals.